Hello everybody. Today we're going to talk about balancing chemical equations, and we're going to use these Kinex cubes. Each one of these cubes will represent an atom, and we have different colors for different elements. I chose what's kind of a standard set of colors, so hydrogen is going to be the white, oxygen the red, carbon is going to be black, and then what else have I got? Nitrogen, blue, chlorine is light green, sulfur is yellow, sodium's violet, calcium's dark green, and then I also have some brown and some orange for any miscellaneous elements that we might need. So first thing we have to do, well, one thing to understand is that the atoms, as the chemical reactions happen, can separate and combine to make new arrangements. So you can make or break bonds, but none of the cubes, none of the atoms can just disappear or be created from scratch. So conservation of mass means there's conservation of atoms. So none of these cubes can just dissolve, right? Or just disappear. Like they're always going to be there. Even if the compound dissolves, the cubes are still there. All right, so we're going to start by building three water molecules. So for water is H2O, so I need two H's and an O. So let me just clear away some of the stuff that I don't need. So two H's and an O, so I need two whites and a red. So this would be one water molecule that has three atoms in it. Notice the angle isn't quite right. The angle should be more like 109.5 because it's bent, and this is clearly 90, but oh well. So that's one molecule that has 1, 2, 3 atoms in it, two hydrogens and an oxygen. All right, and let's make another water molecule. Two, and then another water molecule. 3. So 3 water molecules, H2O, H2O, H2O. So, I mean, in theory, we could use these blocks all the time to do chemistry, but of course it's easier to just use pencil and paper and write H2O, H2O, H2O. Or we could even have Lewis dot structures for these, so HOH with 2 dots. And if there's 3 of them, we'd have to draw it 3 times. So this means the same thing as this, which means the same thing as this. Filling in my lone pairs. But it also means the same thing as just this. So we can just have the number 3 and then H2O. And this is way more efficient, but it can be confusing because students don't understand the difference between the 3 here and the 2 here. So this is a coefficient, and this tells you how many molecules, 1, 2, 3. This is a subscript, and it tells you how many atoms in a molecule. So 1, 2 hydrogens, 1, 2, 1, 2. So there's going to be 3 times 2 total hydrogens, 1, 2, 3, 4, 5, 6, or 2, 4, 6, right? So the coefficient in a way is multiplied by the subscript to get the total number of atoms, but the coefficient tells you how many molecules, the subscript tells you how many atoms per molecule. Okay, and we could also see it in the drawing or in the model. All right, I think you can answer these questions. Then let me turn over the page and let's go ahead and build this one. So now I have calcium nitrate. All right, so for calcium I need dark green. Nitrate, for nitrogen I need blue, and then I need 3 oxygens. And then I'll also need 2 of the nitrates per calcium. So I'll need another nitrogen and 3 oxygens. And that'll be 1 calcium nitrate, and then I'll need to do that again to make the second one. So here's my calcium. Let me go ahead and put together a nitrate. So 1, 2, 3. Oh, that oxygen is broken. It doesn't have a little knob on it. Let's get rid of that one. So that's 1 nitrate on my calcium. And then I need to make another nitrate. So that's another nitrate. And then I'll attach that to my calcium. And so there we go. I have a calcium nitrate. That's just 1 calcium nitrate though. I need 2. So I'll do that same process again. A calcium, a couple nitrogens. Each nitrogen needs 3 oxygens to make the nitrate. And let me snap those together. So you can see that the subscripts tell you how many oxygens, that's 3, are in each nitrate. And there's just 1 nitrogen. We don't have a subscript for if there's just 1. If there's no subscript at all, you assume that there's 1. And that's my other nitrate. So calcium nitrate, I have to combine this one a little differently because of where I put the knobs. Anyway, so we have 2 calcium nitrates, and you could see I've got 2 times this whole thing. So I'm going to have 2 times 1 calcium, so 1, 2 calciums. I'm going to have 2 times 2 times 1 for the nitrates, for the nitrogens, sorry. So 2 times 2 times 1 would be 4. 1, 2, 3, 4. And I'm going to have 2 times 2 times 3. So 4 times 3, 12 oxygens. 1, 2, 3, 4, 5, 6 on the first one. 7, 8, 9, 10, 11, 12. So 12 total oxygens. So that's my 2 calcium nitrates. I just figured that out for you. 2, 4, 12. All right. How many oxygens are represented in each of these? Well, there's just a 1 here. 1 times 3 would be 3. How many oxygens on here? There's just a 1 times 2 would be 4. 2 times 3 would be 6. 2 times 2 would be 8. I think you can do the next one yourself. All right. Then going to page 145, we're looking at sodium reacting with chlorine to make sodium chloride. So my sodium is this violet color, and then my chlorine is light green. Okay, and then I'm going to make the product too, sodium and chlorine. So sodium plus chloride, you need 2 chlorines together, gives sodium chloride. Okay, now you can see what I'm doing here is I'm making a picture of the reactants and the products. Now, of course, what would really happen would be the reactants, like this bond would break, and then you would make the sodium chloride, right? But I'm going to just say, all right, let's say that there's reactants left that could still do the reaction, and there's some product already formed. So you can see there's a problem here, though, because what goes in is 1 sodium and 2 chlorines, and what comes out is 1 sodium and 1 chlorine atom-wise. So that's not balanced because where'd the second chlorine go, right? So we can't have a chlorine disappear, so how are we going to balance it? Well, let's take our sodium and our chlorine down here, and what if we make 2 sodium chlorides? That would fix the issue with my chlorine disappearing. 2 sodium chlorides. Well, that works because now I have 1, 2 chlorines on the left and 1, 2 chlorines on the right. Oh, but now I have a different problem because now I don't have the right number of sodiums. So it's still not balanced. Okay, well, then I can just have 2 sodiums. And now this is balanced. 1, 2 sodiums goes to 1, 2 sodiums. 1, 2 chlorines goes to 1, 2 chlorines. So I need 2 sodium plus 1 chlorine molecule, Cl2, goes to 2 sodium chloride formula units. We don't call them molecules when they're ionic. But anyway, that's that reaction. Okay. We only change coefficients. Notice I didn't change. Naively, you could have said, oh, well, if I need 2 sodiums, I'll have a Na2 instead of an Na. But that is different, right? This is, Na2 doesn't really happen. Sodium comes as individual atoms, so we don't change the coefficients. We don't, like, put a Na2 down here. That's not okay. You put a 2Na. And that's a different thing. 2 things separate as opposed to Na2. Right? All right, then let's look at this reaction. This one actually, it kind of walks you through how to do it, how to balance it. So go ahead and see if you can do that yourself. And then similarly here, there's just some practice problems. I'll go ahead and fill this out and put the answers up for you. But let me give you a hint on page 148. So each reaction is described in words. Methane, CH4, reacts with oxygen, O2. Notice I leave a little bit of room here because I don't know what my coefficients are going to be necessarily, to form carbon dioxide. So when you come to this, you need to remember your naming systems that we had before. So carbon dioxide, 2 oxygens, and then of course you know water. So from here you should be able to balance it once you get to this point, but for this whole page you're going to have to translate words into formulas before you can get started. All right, that's the lecture for today. You can look for the answers on a PDF coming up soon.